So let's look at practice 1 for handout G to N, functional group nomenclature. So we look at this compound. The first thing you want to figure out is what are the functional groups present here. So you see that there is an OH and another OH group present. You will have to recognize that this is an alcohol. You will have to remember that the names of alcohols end in OL, all, alkanol. Because you have two alcohol groups here, the ending of the name would be some kind of a diol. Then you go and look for the longest carbon chain, if possible, one that contains both of these OH groups. So we look for this chain here, 1, 2, 3. This is a 3-carbon chain, so that should tell you that this is some kind of a propane derivative. So it is coming from propane. And in this case, our numbering is correct, going right to left, because we get the smallest numbers for the two alcohol groups. If we had gone left to right, our alcohol groups would have gotten 2, 3, whereas going from right to left, I'm getting a 1, 2 numbering for my alcohol groups. So I will pick this numbering over the other one, which leads me to name this compound as propan 1,2 diol. So watch how we use hyphens when we go from numbers to words or words to numbers, and we use commas when we go from one number to another. So the propan part of the name says there are 3 carbon atoms in this chain. The 1, 2 is the location or the locant of the 2 OL alcohol groups. The di says there are 2 such groups in this molecule. Let's look at another example of alcohols. So here we've got 1, 2, 3 OH groups, which tells me that this is some kind of a triol. 3 alcohol groups. On top of it, we have chlorine as a substituent. In terms of priority, alcohol has higher priority than chlorine. Is more important, therefore the alcohol will take the ending part of the name. In organic chemistry, whoever is more important gets the family name. Now let's look at how we can number this, either going left to right or right to left. So what I get here is a 2, 3, 3, because there are 2 groups on carbon number 3, 4, 4. However, if I numbered this going right to left, I would get 1, 2, 3, 4, 5, which would give me 3, 3, 4, 4, 5. So at a first glance, when you look at this, you might think, well, I should go with this lighter pink numbering because it gives me a smaller first point of difference. This is where you want to be careful when you're doing naming that involves functional groups. The goal here is to give the lowest number to the most important functional group, which happens to be the alcohol in this case. So we want to give the lowest possible number to the alcohol functional group, which comes from the dark pink numbering, which gives a 3 to both of these alcohols. So you will in fact pick this numbering and not pick the first lighter pink numbering like we had done with just simple branched alkanes or alkenes. So then the name of this compound becomes, we name the prefix first, so we would say 4,5-dichloro, and the longest carbon chain is 6 carbons long, so this is hexane triol. So we can either write the numbers first, 3, 3, 4 hexane triol, or you could write this as the same thing as above, 4,5-dichloro hexane 3,3,4 triol. Again, please notice that we have used the hyphens going from numbers to letters or letters to numbers. We have used commas to distinguish between numbers. Another important thing to notice here is that we wrote hexane. We wrote that ending E of the hexane. We did not write hexanol. So if you have only one alcohol group present, you would write hexanol. But if you have more than one hexane group present, you would write hexane triol. The E gets reinserted when you're adding a consonant of the T as the consonant. The functional group here is an ether. You will have to know that a COC is an ether functional group. You will also have to know that the IUPAC name for ethers is alkoxyalkane, where the alkoxy part of the name comes from the smaller carbon chain. So in this case, you have one side that has one carbon atom, you have the other side that has two carbon atoms. So the one carbon becomes alkoxy, so it becomes methoxy, and the two carbon chain stays ethane. Let's look at another example. We look for another ether. So you have the COC bond here, and that's what tells you this is an ether. Now let's look for the smaller carbon chain that would become the alkoxy part of the name, and the larger carbon chain would become the alkane part of the name. So here you have again a CH3 group, which is the smaller carbon chain. So this would be some kind of a methoxy group. But then what is the longer carbon chain? Let's count. 1, 2, 3, 4, 5. Again, be careful. Let's number from the other side as well. 1, 2, 3, 4, 5. In both cases, the ether group, the methoxy group, is coming on number 3, which means there is no first point of difference for your methoxy group. But there is a difference in where this another substituent CH3 shows up on this chain. And the CH3 gets a lower number of 2 if I use the numbering going right to left. So then that seems to be the preferred numbering. We will go from right to left. The main chain is 5 carbon atoms long. So the name is some kind of a methoxy pentane. Let me decide where to put this methyl group, which starts with an M, and this methoxy group, which also starts with an M. So we will go in an alpha order. Till METH, they are both the same. So I'm going to ask myself if Y comes before O in the alphabet. No, it doesn't, which means methoxy must go first. Then I will write the methyl group and add that to the pentane. So then the complete name of this molecule 3 here becomes 3-methoxy 2-methyl pentane. Let's look at a couple more. So you will have to recognize what the most important functional group in this compound is. There is only one functional group, and that is a carbon-oxygen double bond. Because this carbon is flanked by 2 other carbons, this should remind you that this is a ketone functional group. Now, another thing you will have to remember that the names of ketones end in ONE, which we don't read as one, but instead call them ones. What kind of a ketone? Let's find out the longest carbon chain here. 1, 2, 3, 4. So this is butanone. What else is present on this butanone? Well, I've got a methyl group, and I ask myself, what is the smallest number I can give to this ketone functional group? If you numbered from right to left, your ketone functional group would actually get number 3, which is larger than 2. So we do not need to do that. Let's just sit with the left to right numbering. Let us locate this methyl group and locate where the keto group is present on the 4 carbon atom long chain. So giving those 2 locations, the complete name of this group becomes 3-methyl. Either you write 2-butanone or you can call it 3-methyl butan 2-one. Taking up another example of a ketone group, to recognize a ketone, you need to see that there is a 3-carbon chain on which there is a carbonyl carbon present. 3-carbon atom chain which has a carbon-oxygen double bond. Then let's go looking for the longest chain here. So I can start numbering from this side. 1, 2, 3. That gives 3 to the ketone. 4, 5, 6. If I started numbering from the other side, I would get 1, 2, 3, 4 for the ketone group. So I don't need to do that. I will pick the left to right numbering. Then let me look at what are the other substituents present on this. So there are 2 methyl groups present. So let's include those methane groups as part of our hexanone. So then the complete name here becomes 4,4-dimethyl 3-hexanone or hexane 3-one, whatever you like. The functional group here is an aldehyde, RCHO. You will have to recognize that. you will have to remember that the names of aldehydes end in AL. This is different from those of alcohols which end in OL. So O and A is not a spelling mistake in chemistry. It changes the meaning of your name. You have to remember that you start the numbering at the carbonyl carbon. So this becomes 1, 2, no point going to the left. So we'll go to the right, 3, 4 carbon atoms. You can ask yourself the question, once I'm here at 3, should I go down to 4? No, you should not, because if you did, you would get a much more complicated substituent and you do not want that. Since in both cases, you're getting a 4 carbon atom chain, you should pick the carbon chain that gives you the least complex substituents. Or another way of looking at that is to think of picking the carbon chain that gives you the most number of substituents. So then this is a butanol. Butane, because you have 4 carbon atom chains, and then you've got some substituents on that butanol. You've got 2 fluorine groups, you've got 1 methyl group, M, F. F comes before M in the alpha order. So the name of this compound becomes 4,4-difluoro-2,3-dimethyl, and I just noticed I forgot to circle that, dimethyl butanol. So those are some examples from practice 1. We will take up more practice questions in other video.